to the RD2GD application video. This application was built as part of our final project for the class E6895 Big Data Analytics Advanced Spring 2017 at Columbia University. My name is Jose Alvarado from the Data Science Institute, and I collaborated with Itai Karen from the Electronic Engineering Department. RD2GD stands for Relational Database to Graph Database Migration. So our purpose in this application is to migrate data from relational to graph. That's why you're seeing on the right side the graph, which are composed of edges and nodes. And in the other side, we're seeing the relational. So what we're looking at here is a graph to relational entity mapping. This is what we call an entity mapping. Also, we are going to see pretty soon a field mapping. We also have a detailed mapping on this, a detailed panel on this side that is going to show us detailed information about edges, nodes, or any of the entities, any of the tables in the relational. For example, if I click on edges, you automatically could see information about fields in that edge. It tells us general information. It telling me that I click on the edge node. It tells me the number of rows. In this particular case, of course, is 0. It's more relevant for tables. And it shows me the fields. In this particular case, we're seeing that for the graph, particularly for edges, we have an ID, we have labels, we have the node ID 1, node ID 2, and it giving us the type and a short description as well as comments of this edge, which is giving us a definition of what is an edge, telling us that an edge is a pair of nodes that specify a relationship between them. If I click on nodes, I see the information for nodes. So we have a main menu on top, like any other application that we usually work with. And we have 5 of them. We have the connection, we have the data model, we have statistics, arrow, and migrate finally. A connection menu provides access to 2 menu items, the connect menu item and the disconnect menu item. The data model have several menu items. We have the add relational tables, subset relational field, add constant label field, add node property, add edge property. Notice that all of them in this particular case are disabled. There's a lot of logic coming handy here with the menus. Only the menu items that are relevant at the moment will be enabled. The rest will be disabled. The reason why all of these menu items now are disabled is because we haven't established a connection to a relational database yet. Therefore, there's nothing to do. So we have statistics. This menu will come in handy when we are going to generate field statistics. Arrows, I'm going to explain what arrows are. So we click on arrows, this will enabled. And finally, once we connect to our relational database, we bring our table, we set our fields, we do our mapping using the arrows just by dragging and dropping. We mark those arrows are complete, and once we accomplish that, final step is to create the migration of the data. So let's go ahead and start by creating a connection to the database. So I'm going to press connect. That's going to bring a pop-up window, and we have several options here. We have of course, the relational database manager system. As of now, the application is supporting MySQL, that is selected by default. We're supporting SQL Server, Microsoft SQL Server, Oracle, PostgreSQL, Microsoft Access, and Amazon Redshift. For this example in this video, I'm going to use a local instance of MySQL, so I'm going to leave that by default. We have to specify the server IP or host, and optionally a port number. I mentioned that this is a local instance, so it's 127.0.0.1. It's going to be my local IP address. A name of the database that we're interested in bringing or doing the migration to a graph database. In our case, it's called .graph. The username and the domain, in case that applied. I'm going to enter my username in my local database, and of course a password. Now this button here is to verify the connection before we actually try to connect. The second one is to connect without verifying the connection, and the third one is to cancel the window. I'm going to test the connection. It told me that we were successfully connected to the graph on 127.0.0.1. Press OK. And since I'm successfully connected, I'm going to press OK, create a connection. So what that is doing is creating a connection to a database. It's creating not only a connection, but it's creating a connection pool that would allow multiple threads to have their own connection so that we can execute multi-thread queries on the database and take advantage of multiple cores on your machine. So now that I created that connection, in the data model, now we have the Add Relational Tables menu item enabled. So I'm going to click on relational tables to tell the application which relational table within that database I'm interested in migrating. Notice that in this particular case, in our example, we had only 3 tables, and what we're trying to do is now going from the tables to select to the tables that are selected, and we just can press this button and it will select everything, and I can move it to the right pressing this other button here, or I could remove some of them if I like. Once I selected, probably could change my mind, I could remove those ones. So let's say, for the sake of an example, I'm going to pick these two relational tables, and I'm going to press select. Now the application immediately creates the tables in the relational side that I selected. What it's doing also is going into the database for every table that I select. It's going into the database and it's getting all the fields with their data types, the maximum length, and a description is available, and calculating the number of rows in each single table. It's doing this in a multi-thread fashion, so there's one thread by table. So if I click now in each one of these tables, I could see that I could get detailed information in the right side, as we saw previously with the graph. But this one is coming from a relational database. We see the detail and the general information that give me the table name and give me how many rows that it has. In this particular case, we have 5 million records. And it tells me the fields. Tell me the field name, the data type of that field with the maximum length of that field, and a description, if available, in a database. Now this application is very interactive. I can move columns around. You could filter them if you like to see, for example, by data type. Same thing with the tables itself, these rectangles itself, I can move them up and down. So it's very interactive, and we try to design it in a very user-friendly, very intuitive way. So going back into the fields, we noted that this particular table has several fields. It was not normalized, so we have way too many fields in here. We provide the user an option to subset these fields. By default, the application will bring all of the fields in the relational table. But if you're not interested in bringing all of these or migrating all of these into a into a graph database, sorry, um, that's why we provided an option that allows you to subset the relational fields. So I'm going to subset, given that this one had way too many records. Too many fields. I'm going to subset and only choose the field that I'm interested in bringing to a graph database. So notice that we have first the table name, dot, and then the field name. So the first the first field, the first table, this is all of the fields, MPPIS. For this table are related to providers. Let's say I'm only interested in bringing the first name, the gender, the last name, and an identifier for the provider. I'm going to bring those over. So now for the second table, I'm going all the way down, and we have for the second tables the shared patient table. I'm going to bring the MPI1, MPI2. Remember, this is for edges. So edges come out of a node and it end of a node, and this is what identifying that node. It's going to go from this node to this node, and I'm going to bring a property that is going to be the total number of shared patients between these providers. So I'm going to add that to my list, and at this point I'm done, so I'm going to press OK. So now, immediately if I click on the shared patient, we can see that it only contains the fields that I subset. In this particular case, this is a pretty this is a table with a decent size, so 65.7 million records, and we selected 3 fields, and from the provider's data provider table, we went from several columns to only having 4 that were the one that we select. Now the next step at this point is either we can, if we're interested, we can calculate statistic of each of these fields. And the statistic at this point in the application is just only providing the unique values for each field selected, a frequency, and a relative frequency. And that is done by the statistic menu on the generate field statistics. So if I click on that, that will generate multiple thread as well. It will generate one thread per, per field, and it will calculate what I just mentioned. So let's go ahead and do that. What it's doing, the application is the background, is calculating the statistic for us, and we can continue working with our mapping from relational to graphs, and this is a multi-thread application. The GUI itself is not going to freeze while the application is doing work in the background. We have to start creating our mapping. So if I move my cursor close to a rectangle, it shows a little triangle. If I click on that triangle, I can move the arrow and said, okay, this relational table contains node information, and I just let go of the mouse and the arrow got dropped. And the node started telling the application that this particular relational table contains my node information. And in our example, the shared patient is the table that contains our age information. So I'm going to drag that as well to the age information. So now the application knows what contains the ages, what contains the nodes. Now we have to map particular, so this is what we call the table mapping. Now we need to map the field. Now we have to activate or enable the field mapping in order to tell the application what fields in particular contain what property of the edge or nodes. In order to do that, we can just double click on the arrow. But before I do that, I would like to mention that if I just do a single click on the arrow, since that the colors of the arrow change to green, and in the detailed information, I have now, or we have now information of the arrow. It's telling me the source, the relational table called MPPIS, and the target is the graph node entity, graph nodes. This text box over here is giving me a space to document or document the logic behind this mapping or any comments that are related to this mapping. So this application not only allows you to migrate the data itself, but also document the process so that somebody else could understand the way you were thinking and why with this table contains no information. For this example, I just going to leave it as is. So if I want to now activate or enable the mapping of fields, I just will double click on the arrow, and by double clicking, now the graph field mapping, as you can see in the border title, it gets enabled. And notice that the table mapping got filtered and we only see the tables that are relevant to these fields. So we know that these relational fields belong to this particular table and these other fields in the graph belongs to the node. So this is my field mapping. So now remember before that I actually press on the field statistics. So if I click, let's say on gender, look at now in the detail panel, it tells me that gender, the field name is gender, the data type is car1, and it gives me a description, and that is coming from the relational database. And now it showed me the statistic that I mentioned at the beginning because we calculated this. Of course, it's optional, but we decided to compute these statistics. And it's telling me that in this particular data set, we have roughly 1.5 million males and 2.3 million females for a 44.86% and 29.85% respectively. And we have around 25.3% or 1.3 million records are empty. So this is the statistics that we decided to calculate at the beginning. They're completely optional, of course. And so now let's do the mapping. Let's start doing the actual mapping of the fields. So MPI is a national provider identifier. So this is going to be my node ID. So I'm going to drag the arrow right pointing there. In this particular instance, know that for this application, the labels, each node should have a label, and it's very important to have that. We do not have a label coming from a relational database. That we don't have a labeled field here saying that these information are provided so that we can map it to label property in the graph side. So for that reason, we added a menu item called add constant label field that is precisely for providing a user with a constant label that then will be assigned to the labeled entity in the graph side. Like I mentioned before, these are providers. So I'm gonna name a provider, press OK. Notice that the provider, a rectangle, got immediately added to the relational table or the relational side, and I'm going to drag the arrow to the label indicating that that is my property. And now notice that I still have three fields and I don't have any graph property, and that's because this is the default graph properties. So we need to add additional graph property to the nodes so that we can map these other three fields to that graph entities. So to do that, we once again go to the data model menu and we add a node property. Please notice that these menu items also include what we call an accelerator key. In this particular instance, is the key, the combination of the keys Alt and N. So we don't have to keep moving the mouse all the way to data model menu and then down to the menu item. We just press Alt and we get the same window. So we need a graph property for our first relational table called first name. So this is the name, the way I want to name that property in the graph. So I'm going to call it graph name without any space just to make a difference and name it differently. I'm going to press OK, immediately map on the graph side. And as I mentioned, we're going to use the accelerator keys in this instance. So I'm going to press Alt N and it brings the uh, graph property, and I'm gonna name it gender for the gender relational field, and I'm going to do the same for the last name field. Alright, so now we have all we need, so let's do the mapping. So first name, go with first name, gender, go with gender, last name, go with last name. So we're done here. So in order to go back to the table mapping panel, I'm going to just press anywhere in the table mapping panel. It will take me back, and I will need to mark. Notice that at these points I cannot migrate data. That means that the applications know that it's still thinking that the job is unfinished, so I had to mark these arrows are complete. I do that by just clicking on the arrow, going into the arrow menu and mark it as complete. Mapping field, so double click on the arrow, it brings the field mapping, and we proceed to do the mapping. So the MPI1 is where the edge is originated, so I'm going to map it to node ID 1. MPI2 is where the edge finish or the destination of the edge. I'm going to map it to node ID 2. In this, I'm going to add a constant label field for the edges since I don't have one. in the relational side, and I'm gonna name it share patient with. Press OK. I'm gonna map this to the label, and I need also a edge property for the total share patients, and I'm gonna map my patient total to my new edge property called total share patients. I don't have an edge ID, and in this particular case it's not required. So I'm basically done here. So I'm going to go back to my table mapping by pressing on anywhere on the table mapping panel, and I'm going to mark the arrow as complete. In this particular case, we are done. We did our table mapping, we did our field mapping, and we are ready to do our migration. So let's go ahead and do that. So we click on migrate the data, and it's asking me where do I want to save the file generated by the application. The application will generate as many files as arrows do we have here, in this particular case 2, and it will generate an additional file that will contain the script or the shell script that will generate the migration to Neo4j in this particular case. So I'm going to select for now a desktop, and I'm going to press save. So in this particular case, what the application is doing is generating multiple threads to get the data out of the relational table into the files, and it will create an additional thread that once the files are generated, it then will call Neo4j import to import this file. So there have to be here some kind of the application have some kind of thread communication, because the thread that generate the thread that code the Neo4j import command needs all the files to be finished and populated before it actually do the import. So Java, in our case, we're using a Java class that it gets notified when all of these threads that are created in the file are done, and it therefore execute. In the meantime, it's just waiting until it gets notified that everything is done. So if I go to my desktop, I could see that the files already got created. We have, going to move a little bit to the side so that it could be seen. So this is the 3 files that got generated by the application. We had the edges, and with the label that we provided to the edges, and we had the node file with the label we provide to that node file, and then we had the Neo4j import with the Neo4j commands. So these files are already ready for the import, and the application creates the data is already loaded to Neo4j. It does it as well, but it creates this for you to have it and see the data and being able to recreate the import. So if we look at the files, just gonna let's look at the first couple of records in the nodes. We have a header, so we say this is the properties that we created in the graph. So we name it gender, the property graph for the node property, we name it first name, we name it last name. And then notice that MPI said that it's an ID. This is very important. This indicates Neo4j that is the node ID. And similar with the edges. So we have the MPI1 is telling Neo4j with this command that it's the start ID. MPI2 is the end ID for that edge. And we have one property called total share patients. And we could see some of the records that we bring to the database. So if we take a look at the actual command, we see that it's actually saying calling Neo4j import into, notice that the graph, the name of the graph that is going to import the data is the same as the name of the database that you connect to. So that's why it's called .graph.db. It's ignoring entry string. It's skipping bad relationship in case there are some of the nodes in the relationship are not in the nodes. And it's telling Neo4j that the nodes uses the label provider and the location of the file, and the relationships uses the label share patients, and we have the location of the relationships.